So basically, to summarize this video, all you really need to know is one thing and the rest sort of follows suit from that. And basically, when you say strong, you're basically just saying that it all dissociates off into its ions. And so pretty much the reaction goes as it says, and that's why there's the arrow there. Okay, so a strong acid, basically all of the acid breaks up into H pluses, and a strong base, pretty much almost a lot of the OHs are broken off into solution. So just to go into a little bit more detail now, so completely dissociate. So the word dissociate is the scientific term that we use, and strong bases completely dissociate as far as we're concerned. So usually in science a factor of 3 sig figs is considered significant. If it's more than that, we need to consider whether it's significant and whether we can assume it to be zero, etc. Okay, and so on top of that, there's also another term here to know that di, which means two, and there's a triprotic at the end, that there actually is more than one proton that comes off. So sulfuric acid will actually act as a stronger acid because it'll have double the amount of H pluses coming off, just because if they're both 1 molar concentrations. Okay, as I mentioned the word concentration while I've done that here, I will mention it again. So this is talking about concentration can be high or low, and that's different to whether it dissociates well or not. So if it doesn't dissociate very well, it can still be a concentrated weak acid, and also it can also be a very dilute strong acid. So it may not have a lot of hydrogens, even though it's a strong acid, because it may be very dilute. All right, now I'm going to talk about that more than once in this video. So here we go, weak acid. So weak acids partially dissociate, and you may or may not have done equilibrium yet. And so partially dissociate, we do this double arrow here, and that's to indicate that there is a certain amount of the reactants that haven't actually turned into products. And that's what we call a weak acid or a weak base in this situation, because just because it has that equation doesn't mean the OHs have actually popped off. Sorry, that's not an Arrhenius base there. So it would have been better, but an Arrhenius base may be more difficult to find. Oh, here we go. There's an Arrhenius acid at least. So the H pluses have come off. And you can see that this is vinegar. Ethanoic acid is vinegar. You can see that a lot of it just actually stays like that. So vinegar doesn't actually completely dissociate. Once again, in most circumstances, such as in the supermarket, it's actually a dilute concentration of vinegar, so it doesn't actually hurt you, but you can actually have concentrated weak bases that can actually hurt you. So vinegar can be concentrated and can be just as dangerous as a concentrated acid. So the strong and weak acids and bases can both be concentrated and cause damage, and of course they can both be dilute and not do much at all. So strong acids, strong bases can be diluted out, such as 0.01 molar, and be have far less hydrogen ion concentration than your stomach acid, say, for instance. Okay, so hopefully not confused. That's the issue with this, weak and strong versus concentrated and dilute. So weak and strong basically just indicate how easily the H pluses come off, which concentrated and dilute tell you whether there's how much of the substance there is in the solution. And so experimentally, we can compare the two. So we can either look directly at their pH. We can look sort of at how well they conduct electricity. Basically, if there's more ions in solution, such as H pluses, and obviously the OH minuses, and obviously their counterpart ions as well. That's also an indicator of how strong the acids and bases are, as long as they're at the same concentration. Same with here, they must be at the same concentration. And weak acids also react more slowly than the strong acids, or weak bases react more slowly than strong bases, because they don't have their ions coming up as quickly to react. So I've just recently updated this slide to make it clearer because even year 9, 10 students are getting it wrong because they're not memorizing this early enough. And you definitely need this for your 11 and 12 exams, and it's not in the data booklet. So make sure you've memorized. You can work this out that it's like H2SO4, so it gives 2 H pluses. So make sure you've memorized HCl, HNO3, H2SO4, carbonic and phosphoric acid as well. This, trust me, will get a lot easier once you've done year 12, but for the meantime, I would memorize one of them. Ethanoic acid is a carboxylic acid, and I've just thrown in methylamine just so you recognize that NH2 acts like ammonia in the same way. They've got this lone pair hanging off here, which the H pluses cling to when they hydrolyze water to give the OH minuses that come off. So they're not, they're Bronsted-Lowry and they're not Arrhenius. Everything else here is Arrhenius. The other ones here, so any group 1, so lithium, potassium hydroxide, and then barium hydroxide as well. So I'd make sure you have that whole complete table memorized because you're going to need that to be able to solve questions. They're going to be questions that say things and you're just going to have to know what the formulas are for those. So lastly, just adding on, there are such things as triprotic acid, so the phosphoric acid that I mentioned before, and there's the pKa values for those that have done the equilibrium. And lastly, weak versus strong, concentrated versus dilute, just a picture of those so you can maybe to get that in your head perhaps. So this is a strong and dilute acid, so you can see there's complete dissociation, but there's not much H pluses there, where the H pluses the blue ones. Whereas you can have a strong and concentrated, so there's complete dissociation in both of these because they're strong, but there's lots of H pluses because this one's concentrated. There's not many there because it's dilute. You can see a dilute weak acid has pretty much no H pluses because there's not much there, and the bits that are there are not giving off much H pluses. Whereas a weak concentrated acid can actually be dangerous. There are lots of the reactants there. There aren't many of these H pluses coming off still, but you could still raise it to this level just by making it even more concentrated still. Okay, so there's a picture of concentrated versus dilute and strong versus weak.